Congruent triangles. Remember, whenever you're proving congruency, or similarity for that matter, you need three pieces of information. You're basically looking for three facts to prove it. If you're really unsure, look for the side, because every congruence proof involves at least one side being the same in both. So if you're unsure, maybe that's a point to start. So the tests, you'll remember them. We have side, 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 where in fact all three sides correspond to the same as the other one. So SSS we often abbreviate that with, and there we go, there's a little diagram demonstrating, oh look, there's one side the same. What do you know? There's another. Oh, there's even a third. So, congruence. Then, we remove one side, replace it with an angle. But with side, angle, side, the important thing is it can't just be any angle. It has to be the included angle. That's why we write it as side, angle, side, to remind ourselves that the angle has to go in between the two sides that we've identified as being the same. So in this particular diagram, there we go, we have a side, we have another side, but it must be those angles that we show are the same. So got to be the included one. Alright, so then remove a side, replace it again with another angle, and we get angle, angle, side. So here we go. We have one angle that's the same. We have another angle that's the same. And again, with the side, it has to be in the same position in both triangles. So it has to be the corresponding side, or the matching side, some people say. So in this case, the diagram I've got, it's the one opposite the green arc. Alright, then there is this special one, right angled triangles. So if you know the triangle is right angled, you also know that their hypotenuses, or is that hypotenuse, whatever the plural of hypotenuse is, they're equal, and there's another side. So you've got the right angle, the hypotenuse, and another side. That's enough to show congruence. Because I suppose, with that information, you could actually prove any of the other three. See if you think about it. You could use Pythagoras' theorem to prove the third side was the same. So you'd have side, side, side. You could use trig to show that the included angle is the same, because it's got the same cosine ratio. Side, angle, side. And in fact, you could use trig again to say, well, hang on, I've got the right angle and another angle, two angles in a side. So that's a special case which really covers all three of the other proofs. Alright, let's do an example of an HSC one from a very long time ago now. So there's the diagram we were supplied with. Information we've been given, AC, BD, intersect at right angles, DAS, BAS. And what you find with HSC questions, and hopefully our assessment task questions as well, is that they give you the information in two ways. One, a diagram, one in a description. And hopefully the two match up. We're going to prove that DA is the same as AB. Alright, well, what do we know? They told me that DAS is the same as BAS. Now, some people like to, after their reason, just write down, oh, well, I've got an angle. Because remember, we're looking for three facts that are the same. So they just sort of listen, okay, I've got one of those facts. AS is the same in both of the triangles I'm going to end up using. And DSA is equal to BSA is equal to 90. Okay? Now, notice, look, yes, in the diagram, it's angle DSC, they've said is a right angle. But as soon as they label one as a right angle, I mean, they're not going to label all four. It is okay to say the others are right angles as well. You don't have to do an angle sum of a straight line, therefore this one is, or vertically opposite, therefore this one is. If they tell you one, they mark one in as a right angle, it is okay to assume all four are right angles. Okay, well, I've got it, haven't I? So there we go. I've got angle, angle, side. So therefore, DA is AB. I've used the phrase matching size in congruent triangles. It's probably what most people use. It is okay to say corresponding sides in congruent triangles. Remember, the word corresponding means in the same position. Now, some people get confused with corresponding angles in parallel lines, but if you think about it, it's the same thing. Because corresponding angles with parallel lines, they're in the same position. So it means the same thing. But as I say, to avoid any confusion, sometimes we just use the word matching and then that solves that problem. Okay, we're now going to prove DC is equal to CB. So, we just proved that DA was equal to AB. I've got a side. Again, I'm going to use this angle, DAS and BAS, the fact that they're the same. But now I'm going to use the larger triangle. I'm going to say, well, AC is common in both. I've got my 3 pieces of information. This time I'm using side, angle, side. So yes, DC is equal to CB. Again, matching sides in congruent triangles. Alright, types of triangles. Just a couple of things to point out. We have our good old isosceles triangle. Now, if I want to use the fact that this is isosceles, AB is equal to AC, I tend to say equal sides in isosceles triangle. And I'll name it if there's ambiguity. I suppose I didn't really need to for this one because there's only one triangle. But if there's more than one triangle there, it's a good idea to name it. So whoever's reading your proof is directed exactly to where you're talking about. And if it was the angles, equal angles in isosceles triangle, some people use base angles. You might have seen that phrase, base angles in isosceles triangle. Now, the way to get around, if they haven't told you it's isosceles, well, they've just told you these 2 angles are equal, and you want to say these 2 sides are equal, there is another way of doing that without proving the isosceles triangle. And that is, and some of you may have used it before, do you know what I'm talking about? Yes, the sides opposite equal angles are equal. So you could use that proof. And with an equilateral triangle, of course, all 3 sides are equal. Now, this is interesting. I've got equal signs. I've got more than one on a line. In a geometrical proof, that is acceptable. Now, in an equation, it's not acceptable. But in a geometrical proof, because I'm simply listing all the things that are equal, I'm saying, well, look, AB and AC and BC, they're all equal because they're sides of the equilateral triangle. And for the angle, not only will I say they're all equal, I'll actually tell you what it is, because if they're all equal, they of course have to be 60 degrees because of the angle sum of a triangle. And so they're the equal, well, I don't have to say equal angles in an equilateral triangle because they're all equal. So they're simple just angles in an equilateral triangle. Some terminology with triangles you may or may not be aware of. An altitude is another name for perpendicular height. Okay? So perpendicular goes from a vertex and is at right angles to the other side. So that's an altitude. A median also comes from the vertex but joins up the midpoint of the opposite side. So that's a median of a triangle. And then the right bisector also goes through the midpoint, but it's at right angles, which means it might not go through the vertex on the opposite side, because it's got to be at right angles to the edge. So there are 3 types of lines in a triangle. You might see those words. Alright, let's play with HC.